Hello everyone. Today we're going to talk about the selection sort in its time complexity. In the previous video we talked about the insertion sort and the exchange sort and like the average and worst case for like when we are considering the comparison of the keys or when we are considering the assignment of records. Okay, so similar to the exchange sort, okay, the selection sort has the same like the number of comparison of keys, okay, on the worst case. So we have, as you see, I goes from equal 1 to n minus 1, and also j goes from I plus 1 to j minus 1. So this condition here, we have that this if condition here, okay, no matter that what's going to be the output, okay, we'll have these comparisons. So similar to what we had for the like the exchange sort, the worst case going to be like the n squared divided by 2. And again, it's not hard to see that. Okay, the reason is that let's see that how many comparison we have when I is equal to 1. So when I is equal to 1, j is equal to 2. Okay, so and j goes from 2 to number n. So the number of comparison will go from 2 to n. Is going to be n minus 1. Okay, then when I is equal to 2, j becomes 3, so it's going to be n minus 2 comparison. And if you just, it's a very simple sigma that if you just write for I minus 1, and I goes from 1 to n minus 1. Together it's going to be n squared divided by 2. And for the assignments, okay, the as you will see, the selection sort works better than compared to the exchange sort. In the exchange sort, okay, so we were doing the like the assignments every time, but here we have the comparison at the end of this, like the inner for loop that we have here. So as you see, this is after we're done with this for loop. So, and every exchange or every swapping the numbers, as we said, has 3 assignments. So just using some temporary variable, okay, there are 3 assignments. So 3 assignments for each of this one. And as we said that this is based on the number after the second loop, okay, so it's all about the first loop. Okay, so and the first loop goes from I equal to 1 to n minus 1, that is together is going to be n minus 1 minus 1 plus 1, that's going to be n minus 1. So we have n minus 1 here, okay, the number of times that we are calling this exchange function. And exchange function, okay, has 3 assignments. So together, okay, the number of, like the time complexity for the number of assignment, okay, going to be 3 multiplied by n minus 1. So that's for the selection sort. Next, we're going to compare the selection sort, insertion sort, and exchange sort time complexities. Okay, this is the comparison of the algorithm that we talked about so far. So insertion sort, selection sort, and exchange sort. So as you see, also all of them are in place, so they don't need extra spaces. Means that the space complexity for all of them, like the extra space complexity, will be from the theta of 1. So it means that they need a constant extra space and not something that related to the number of items that we have or the input size that is equal to n. So as you see, the selection sort, okay, compared to the exchange sort, it does better. Okay, so both of them has the number of comparison, like the complexity of number of comparison is equal to n divided by 2 divided n squared divided by 2, okay, for the first case. And like for the number of assignment, the selection sort, okay, as we saw, it does almost 3n, okay, or 3 multiplied by n minus 1. So here we're just approximating because we just care about n. So 3n. And for the like exchange sort, on the worst and average case, we calculate that one. So it's equal to 3 n squared divided by 2 for the worst case, and for the average case, that was 3 n squared divided by 4. Also, we did like the analysis on the number of comparisons and also the number of assignments on the insertion sort that shows that the insertion sort on the average, the worst case, okay, does the n squared divided by 2 on the number of comparison, and also similar to the number of assignment, and also similar to the average case of the both average case of the assignments and the comparison are same for also insertion sort, that is equal to n squared divided by 4. And as you see, for the selection sort, okay, the number of assignments, okay, is the best, okay, because instead of like doing the assignment every time, so it does after the second like the first loop is done.